This is Pre-Calc, Section 11.2, Part 2, on arithmetic sequences and series. In Part 2, we will look at an arithmetic series. And all that is, it's the sum of the terms of an arithmetic sequence. There are two formulas. There's the short form and the long form, and you do need to memorize both of them. You would love to be able to use the short form all the time, but you can only use the short form if you know the first and last term. So let's look at some examples of when we would use the short and when we would use the long. So this says evaluate S sub 12 for this arithmetic sequence. Now in words, what that means is find the sum of the first 12 terms of the arithmetic sequence. Now you can only use the short form if you have the first and last term. I don't have the last term. Now I could continue this pattern out for 12 terms and have the last term, but it might be just as easy to go ahead and use the longer form. So we are doing S sub 12 equals 12 over 2. Notice in this formula, this n, and this n are all the same number. Then 2 times a sub 1 is negative 9, plus n, which is still 12, minus 1, times d, which is the common difference. So we need to look back here and see if we can figure out the common difference. From negative 9 up to negative 5, I am adding 4, so that's times 4. And then you can use your calculator right now, or you could clean it up a little bit. So this is 6 times. 2 times negative 9 is negative 18. 12 minus 1 is 11 times 4. Now, that would be about when I would use the calculator. I'm just afraid of you guys doing too many steps at once and just making a calculator mistake. So this is 6 times negative 18 plus 44, which is 6 times 26, which is 156. So do whatever you're comfortable with, calculator-wise, or writing out multiple steps. Use the formula, one of these two, and you choose to evaluate the sum of the first 60 positive integers. This is one that we could use the short form on because the sum of the first 60 positive integers would be 1, 2, 3, all the way out to 60. We do know the last number. The last number is 60. So I'm going to use the short form here. So this is S sub 60 equals 60 over 2 times the quantity a sub 1, which is 1, plus a sub 60, which is 60. And do the arithmetic. This is 30 times 61, which is 1,830. And of course, you can use the long form if you'd rather. This tells us the sum of the first 17 terms of the arithmetic sequence is 187. Symbolically, that would be S sub 17 equals 187. They've also told me that A sub 17 equals negative 13, and they would like me to find A sub 1 and D. I have to decide which of the formulas I'm going to use. This is the sum. This is the last term, because it's the sum of the first 17 terms. This is the 17th term. That tells me I can use this formula. S sub 17 equals n over 2 times a1, which we don't know, plus an. So let's start plugging in. S sub 17 is 187. N is 17 because we want the sum of the first 17 terms, and we know the 17th term is negative 13, so that means n is 17. A sub 1 is what we don't know. A sub n is this right here, which is negative 13. So to solve this, I would go to a decimal. 17 divided by 2 is just 8.5. This is a1 minus 13. Divide both sides by 8.5. And that works out to be 22. So that cancels out. That gives me 22. A minus 13. A sub 1 minus 13. Add 13 to both sides. And a sub 1 is 35. We're not finished because it also asked me to find D. Now the formula I need to use to find D will be the a sub n term formula. The s sub n formula isn't going to help much. So a sub n, which is a sub 17, equals a sub 1, which is 35, plus 17 minus 1 times D. But I do know what a sub 17 is. A sub 17 is negative 13. So instead of rewriting the whole line, let's just erase this and put negative 13. So this is negative 13 equals 35 plus 16 D. Subtract 35 from both sides is negative 48 equals 16D. Divide by 16, and D is negative 3. So those are the two things they asked us to find. Now they want us to evaluate the sum. You know from the previous videos that that summation sign tells get the sum. Now this is an arithmetic series. Now how do we know it's arithmetic? There's a couple reasons. One is because this is the arithmetic sequence and series section, but that's not going to help you out when you see a problem like this on a test or in the middle of a math lab quiz. So one way to know that this is arithmetic is to start plugging in and look at the first couple terms of your sequence. If you put 1 in here, 4 times 1 is 4, plus 8 is 12. Put 2 in here, 4 times 2 is 8, plus 8 is 16. Put 3 in here, 4 times 3 is 12, plus 8 is 20. And you can see that there is a common difference of 4, and as soon as you identify that there is a common difference, that makes it arithmetic. Now why is that important? If it's arithmetic, that tells you what formulas you're going to use. You're going to use one of the arithmetic sum formulas. Pretty soon we're going to talk about geometric sequences in series, and that's different formulas. So you have to know this is arithmetic to be able to use the arithmetic formulas. So now we've decided it's arithmetic. You have to decide, do you want to do the short form or the long form? I could go the long form right now just knowing this information, but because this is going all the way out to 10, I could plug 10 in right here. 10 times 4 is 40, plus 8 is 48. What I have just found there is the last term. Since I know the last term of this sequence, that tells me I can use the short form. S sub n equals n over 2 times a1 plus a sub n. So we want to find the sum. So 1 to 10 means there were 10 terms. A sub 1 is 12. A sub n is 48. 10 divided by 2 is 5. In the parentheses, 12 plus 48 is 60, which gives me 300. Now that's one way to know it's arithmetic, by writing out some of the terms and seeing if there is a common difference. The other thing is this fact right here. A sequence that is arithmetic is linear. Doesn't 4i plus 8 look a lot like mx plus b? So when you see a sequence like this, you know it is linear, which means it is arithmetic. So you can remember that arithmetic idea, or you can just plug in 1, 2, 3, etc., and take a look at a couple of the terms.